If you guys haven't attended one of these before, we do a lot of walking tours and other events, and we are really excited to have you guys here. We have a really great program tonight. We're going to be about a mile, and then we'll end in GW. For those who are not aware, got voluntold to be here. If you guys have any questions about AEI, DC, our upcoming events, in November we have a tower crane climb and an active job site tour that's going to be occurring on the 8th, sponsored by Davis Construction. We're going to be out at a job site out in Reston. We're really excited about that one. If you want any more information about that or how to sign up, please feel free to come to me, or if you're on the board, can you please raise your hand now? So any of them, let them know. If you guys have any questions, let me know. I have any emergency supplies you guys need, and we will be walking. All right, so without any further ado, I'd like to introduce our first presenter, Christine Reynolds. She'll be talking about the Kennedy Center, but before we begin, we're going to walk down a little ways so that we can actually take a look at some elements on the building that she's going to be talking about tonight.
WJU's had a long history at Kennedy Center. Back in the early 90s, we had a 10-year IDIQ, so we did a whole wide variety of projects. I'm only going to talk about 2 of them today. I'm most familiar with them, but if you look at the bottom panels of the stone, you can see a lot of discoloration. That's a lot of staining. They did multiple cleaning studies for it. We sent samples of the stone up to our lab, and we found that it is not dirt or accumulation, it's iron in the stone, and that it is corroding basically and rusting in the stone, and that it's migrating through the stone. And so what we see is where it has water contact, which is basically at grade level and some of the overhangs upstairs, we get this staining pattern that really is embedded in the stone. And so what we told them was it's very difficult to remove that, and it's probably going to be a lifelong issue with the marble. The other hallmark project was the marble panels. All of these panels are about 3/4, 7/8 of an inch that are cast into a 5-inch concrete backup. So they're very thin veneered stone. And marble in particular loses strength over time through a process called hysteresis. And what we found during our studies, you can see a crack panel here, and if you look up above, up at the top at these panels, if you stand and look carefully, there are pins that we ended up pinning these panels back because of the strength loss. So we feared that they would separate. They were going, some were replaced, some were cracking, and we were worried about them separating from the backup. And so we undertook, this was probably around 1995. We looked at this building again around 21, I think it was, right during COVID. And they looked pretty good. We could see some continued going. If you're on the other side by the Potomac, you can see some of the panels continuing to separate. But the pinning itself seems to have done the trick and held them in place.
And those are the pins.
So the panels you're talking about are overhang,
yes.
the front of it. Okay.
Yeah, so the
Okay. Yeah, that makes sense. Okay, because I was thinking they're 2 separate entities. You had the one in like the main.
No, it's not in the main field. It's at the fascia. But pinning is a pretty common repair method.
Paul Parfitt with Wisjani.
Okay, good job.
This is the Watergate complex, obviously. We're going to specifically talk about Watergate West, which is the one at the far end here. But they're all fairly similar. Watergate West was the 4th of 6 buildings completed on this complex. They were all constructed between 1961 and 71. Watergate West was famous actually not for its name, but actually it started leaking before tenants even moved in. So there was actually active lawsuits pending before people were fully moved into the building. One of the things the contractor did back then to try to remediate the problem was, instead of taking out joints and retooling them, they actually grinded away parts of the transite panel, and they just did giant bridge seals across all those joints to reseal everything. Didn't fix all the leaks, but I think it got them enough that they were able to walk away from that project. But we got involved in this building in about 2013. We were doing a condition assessment of deteriorated concrete balconies, as well as the transite panels that are on the exterior. The transite panels, if anybody is familiar with them, is actually asbestos cement panels. So there's a lot of fun things that I got involved with those. What was actually happening is the transite panels have a stucco layer, and then you can see on Watergate East, it's really nice. That is like a white marble aggregate that they impregnated into the stucco. That color used to be the same color as the precast railing pickets, and it has aged over time. And one of the other problems with this panel is it was actually eroding, and all those aggregate pieces were falling down on the ground. So we got reports after heavy rain events that they would just find pebbles on the ground littering everywhere. So one of the things we had to do with this facility was we not only repaired post-tensioning cables that had deteriorated on this building. It was one of the first post-tension buildings in the country. They used an archaic paper wrap system, which works out well in the beginning, but as that paper wrap system starts to fail, it soaks up water, and obviously water and steel and corrosion don't mix very well, and there was all kinds of concrete deterioration on the balcony. So we did about 250 post-tensioning splices, repairs, and re-stranding in that balcony all the way around. And the other part of it was we did a facade restoration when we resealed the entire building, restored the transite panels, and this was one of the first buildings in this complex that had to deal with CFA and the Historic Preservation Board. It was on the National Register in 2005, and when CFA got involved, we kind of set the standard for the other buildings as they're doing these restorations as far as what color they can use, that sort of thing. So CFA was involved with a lot of mock-ups that we had to do, full-scale mock-ups for colors. And the way we were able to get away with that for recoating it rather than trying to clean the building is because if we tried to clean it, all of that aggregate was going to fall off. So we were able to convince DC that the only way to save that historic fabric was to coat it and essentially bring that aggregate back to the building. We picked a color that matched as close as we could the precast railing pickets, which, like I said, was the original color of the building. And so the contractor was able to restore those aggregate pieces. We were able to recoat it, and then we actually were able to restore the joints back to their original about half an inch width, as opposed to, I mean, it was basically like almost 2 inches wide in some cases. So that's what we ended up doing with that. Overall, that project went from about 2013 to 2016. And when it all added up, it started off as a small investigation project. It turned out to be about $4.5 million worth of restoration that they had to do that building. But it was all worth it, I think, for them, especially with Surfside happening, several years later. I think they're glad that they ended up doing that. But that's the gist of that building, if anyone has any questions about it.
This is Luigi Moretti. Is that
yeah, so the whole complex was designed by Luigi Moretti, a famous Italian architect. Originally, the whole complex was bankrolled by the Vatican. I believe they had like a 75% stake in the complex, and eventually it got sold off to each individual entity as they are now. But the engineer of record for this building was T.Y. Lin. If you guys are familiar with him, kind of the grandfather of post-tensioning. So that's kind of why this is one of the first post-tension buildings in the country. Post-tension's been around for a lot longer than that, but mostly on infrastructure, bridges, and so on. So it was kind of one of those ones where they learned what not to do, essentially, with that.
Wasn't like the National Trust or CFA's offices in the building? Weren't they located here?
They may have been. So the office building is where a lot of those places, so it might have been them. Not during our project. They were back down by DCRA at that point. Yeah.
Hi everybody, my name is Ed. I'm with Insight Property Group. We're the owner and developer of the Wray. This building right here. So, just a brief overview. The building was built originally in 1940, being built in the 30s and then finished in 1940. It was originally designed to be apartments, but the State Department needed it. So at that time, the State Department took it, and it was a State Department office from then till about 2020. We purchased it in early 2019 with the goal of turning it into apartments. It was a full gut and rehab of the entire building. This is a difficult, challenging project. There was a lot that we weren't able to find out because of the due diligence was limited. We weren't exactly allowed to go into a lot of the places because it was a secure building with a lot of sensitive information. So that was a big challenge. But as far as the overall construction goes, there's 158 apartments. There's about 20 on each floor. We added a penthouse that you can see a little bit of on the left to the roof for some amenity space, a club room. So with building this, there was a lot of challenges construction-wise. One being room, just for the actual design itself, but also to put stuff down and build. Another is just the age of the building. We didn't really know what we didn't know until we got in there and ripped everything apart. So there were facade issues, structural issues, and David Klein with SK&A was a structural engineer of record, and he can kind of go into the investigative process and how we were able to kind of support everything.
Yeah, so when we first got involved, we were helping Insight with the due diligence effort during the transaction phase and the kind of a feasibility study at the beginning. We knew some of the things that Insight wanted to do to the property, so the penthouse, some of the rooftop amenity spaces, some new elevated levels inside the building for interstitial spaces, some new site walls you'll see out front. So basically we kind of got involved and helped them understand what structurally it would take to allow for the new amenity space in the roof, right? So when the building was originally built, it was designed for just snow lid on the roof, to turn it into a space where you're going to have occupiable space, and also basically adding a new level with the penthouse structure. We helped them understand that we needed to strengthen the roof, looked at all the columns coming down, and helped them understand what the extent of the strengthening would be. Like Ed said, we knew basically nothing about the building when we first got involved. We had no drawings. So while the state park was in there, we got in a couple times, it must have been like 5 or 6 times, getting bits and pieces of the property, kind of understanding it. We didn't even know the beam layout. We knew no column sizes, knew the beam sizes. So that was a major challenge going into it. And structurally, it's a concrete joist system with terracotta infill. It's very popular for buildings in the 1940s in DC. I think some of you may have seen that. It also makes it very challenging to strengthen because there's not a lot, kind of to bite into. I think there's anything else that
Yeah, I mean, just also coordinating that we had a bunch of new penetrations we needed to do. I mean, office building, you got your core bathrooms. We're now got 200 apartments worth of plumbing. It was a lot of coordination, and our design team really did a really good job putting together a really unique project, and I think it was a pretty nice achievement through their hard work and coordination. So, any questions anybody has? Sure.
Like, structurally, how did you end up bypassing the like load path on the roof for the penthouse structure? If you add a load path?
Yeah. So basically, what we were able to do between the terracotta, where the terracotta infill is between the concrete joists, we knocked them out in areas where those post down were coming down, and filled it with basically just build a concrete infill. And where we had to, we were jacketing columns to increase the capacity of the columns down to a certain level, looking at the foundations, things like that. So yeah, we had to study that load path as it worked its way down. So that obviously, because those columns that you're seeing there for those pop-ups, those penthouses, they don't align with the columns, the concrete columns below. So yeah, we had to basically, analyze the slab and create a load path for it, introduce new beams.
Yeah, is this a historic building, and maybe that's why you couldn't just completely demolish it? I'm always curious, did you do an early analysis, is it cheaper just to completely demo it versus all these unknowns?
Yeah, that was definitely a component to it. So yeah, we did work with CFA and the Historic Preservation Board here to maintain facade. We couldn't be too visible with the penthouse on top. That's why you can only see a little bit from here, as well as some of the lobby finishes inside. So there's some old travertine that's all, we think, original. It's tough to really tell, but a lot of the interior finishes on the lobby area, including the floor, are original. So yes, that was a component to the work.
Any repointing necessary, or did you have to do anything to
Was there any repointing necessary? Yes, a lot. We didn't think so originally. The windows were replaced somewhat recently within the last 20 years, but once we stripped everything out and we were starting to do interior finishes, there was spots everywhere. So I wish Janie was part of that effort, and yeah, it was quite extensive.
When you guys were replacing bricks, did you have anywhere to salvage them from, or did you have to find a match and mix them in?
That's a good question. I think it was a mix of what we had and finding matches, to be honest.
Did the Historic Preservation Board have anything to say when you guys were doing that, or?
going back a couple of years now. I think we didn't have to do a whole lot. I feel like the kind of lower floors were more important to them, but I think we had to run it by them. But I think it was sufficient. Yeah. 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 I mean, I think the color wasn't too hard to find. But yeah.
So budget, you said there was lots of unknown things. How crazy did the budget end up being at the end?
I think my original budget was $27 million, just for the hard costs. I think it ended up being like 33 overall.
Okay, so that's not too bad.
Yeah, magnitude-wise, not too bad. Percentage-wise, it was a little rough, but it leased up really quickly, so it ended up working out for us. But yeah, it was fun. It was fun, challenging.
Why did you pick an office building to start with?
It's a good question. They bought it before I started working here. Yeah, I think it's just because it was originally designed to be a residential building, so the bar lengths were, appropriate versus some of the chunkier downtown office buildings where you got 40 feet to the window. It was more appropriately sized, so it penciled out better.
Not going to talk about structural. This is GW Smith Center Arena. We did a 4-phase renovation starting in 2009. That's why I have notes. It wrapped up in 2011. Most of the renovation was done over the summers. So we would mobilize for a little bit, do part of it. They would demobilize and come back the next summer and do it just so the building could stay operational for those years. Internally for summer consultants, it was our first lead project and we got gold on it. And it was also our first Revit project. So it was a lot of firsts, big firsts on a project to deal with. It's 100,000 square feet. It's a $27.5 million renovation. It has 4,300 seats for their Division I NCAA basketball team, among other sports. Gensler was prime on it. So the first phase was really kind of a preparatory phase, and the first floor that they did was still in session, the pool was still in session. The second phase was one of the biggest ones. We set the entire first floor, which is actually this is the second floor that we went out on. The first floor is underneath, more or less. We basically demoed everything right down to the structure, the footers. Because we were putting in the basketball team locker rooms, fitness centers, sports medicine, an academic center, racquetball courts, and redoing their natatorium. In that same phase, we also did the second floor offices and the VIP suites. So in order to do that, we gutted most of the floor slab out to run all of that plumbing for the locker rooms. And we had large existing shallow footers that we had to deal with the plumbing, which was interesting. We had replaced the chilled water plant a few years before with one of the very first variable primary systems in the area. So we already had that in good condition. So we were able to go in and do the heating water plant and also domestic water with gas-fired boilers. It was a little tricky to get air down to the first floor. So we put in a big DOAS unit that basically pre-treated air and took it out to little terminal units that did each space. Because each space was so different from a conditioning standpoint, because we were dealing with steam rooms and fitness centers and then like a studying area. So we had a lot of tricky conditions dealing with humidity down there. And so the best way to deal with it was just these smaller units. So there's about, there's 4 mechanical rooms down on the first floor with these smaller units in it. And some of them are just straight up dehumidification units if they were serving a locker room. Let's see. There's another mech room down there that houses the plant, and then another bigger mech room with that DOAS unit. There's also an auditorium dehumidification unit, and then all of those dehumidification units are on a new dry cooler that's up on the diagonal. We also did 5 new air handlers on the second floor. Some of them were actually for the phase that would happen the next summer, so we had to make certain all of our loads were right in our calcs, so we were planning ahead. We did a new 2500 amp 480 277 volt switchboard and 150 kW generator in the basement, which was fun getting the exhaust all the way up to the roof. The third phase was actually the arena and the concourse and concessions and the toilet rooms, as well as the VIP boxes for the donors. We did 4 new air handlers there's a roof penthouse that's kind of in the center, and we did all 4 of those, and they all served a common plenum that comes down just through the scoreboard, and then the ducts go out from there to serve the rest of that level. And we did all the arena lighting and the new scoreboard with that as well. And then the 4th phase was really exterior reskinning. It was originally just monolithic concrete, and so they reskinned this in front of that, and then did the landscaping with it. Any questions?
Pull in outside air for the
There's an areaway, and I don't remember, it's probably over here somewhere if my memory serves me correctly, but there's a big areaway that we pulled it in from. We were far enough off the street to be able to do it.
You might have mentioned this before, but I missed it. What was the building before you guys got involved?
It was the same thing, they just wanted a facelift on it.
Okay.
Hello, I'm Andrea Del Duce. I'm with WJE. This is the less new but still new Science and Engineering Hall for George Washington University. We finished about 2015. Is that right?
Yep.
This is Brian Nomick. Brian and I worked together on this job. I'll let you.
Brian Nomick with Edgemore Infrastructure and Real Estate. We are a developer. We're affiliated with Clark Construction. When I was a part of this, I was part of Clark Construction. Jewel Box, pretty incredible building.
I'm Martina Driscoll. I was the project manager from Wisciani on this, but Andrea's going to take the, I'll just
kick off. So let's see, we had much of the facade is a unitized curtain wall, which was provided by Harmon. I was actually just reminiscing with Brian. We had an amazing team on this job. It was a really great working experience, great subcontractors, did a full-scale mock-up in the lab with the curtain wall before coming out here. We have the terracotta, we have the sunshades, we have terracotta baguettes. Very interesting and fun assemblies to design. For me, this is the first time that I used an engineered transition assembly at the curtain wall. So that was kind of an interesting design process. So it solves a lot of problems for you, but there was a lot of interesting in and out of plane things happening really throughout the entire project. We were just joking, the curtain wall shop drawings were, no joke, 800 pages on this job.
They were full scale.
Insane. It was a big set though. It took me forever to look at this. So a couple of other PVC roof. We have some full-size trees inside in the plant. Well,
one less.
One less. Okay.
I was in there touring about a month ago. One less.
Okay. Oh, that was a lot of stress getting those trees in there on the interior, making sure it was waterproof, make sure they didn't die. So many things. So some cool things there. Something that's kind of interesting if you were in the enclosure worlds that came up on this job. We were passing all of our chamber tests, our E1105, where you like build the chamber on the interior, spray rock on the exterior. Passing those, everything looks great. It was actually the nozzle test that kept yielding issues as we were going through. So Harmon was amazing. They did an amazing job with QC. They had guys out here doing the nozzle testing. We tracked down all of the issues. It was primarily sunshades at the back pans and detailing around the knife plate there. And they tracked all of them down, but it was kind of an interesting little nugget for us, because usually the nozzle testing is great, and then you get to the chamber test and something shows up. So that was something that stuck with me. Brian, what was your takeaway?
This was a long project. So what you wouldn't know, even where we're not into the sidewalk, but almost right along the building line, 85 feet down. This was the deepest private excavation in DC at the time. I don't know if anybody passed it. 5 floors of garage and building below grade. But what's really unique are the boxes of air that are inside that we had to build around. And so there's a vivarium, there's a clean room, there's the biggest, I don't know if we have time to walk around the building, but the biggest strong wall on the East Coast for structural testing is over on the far side of the project here. Transitions galore through the garage to get to the frame that you see here. And we'll get a peek in the lobby, but it is wide open. with an open atrium, plenum, and a connecting staircase and fishbowl labs right up the center. I was just sharing that one of the really neat things is this is not a cheap facility, but when you invest in this, you expect millions of dollars in research funded by the best faculty you can get, and then the best students, the best researchers. They're doing it here. I mean, this launched them into a new trajectory of research that they've made good on. But this was a 5-year build plus 2 years for the University of Programming before, and so it really was inside out. A lot of constraints around how it goes. So to create that architectural distinction, ins and outs everywhere, little subtle ins and outs. But from an engineering perspective, a lot of work on the handoffs between the design and the people doing the work on those things. So there's a manual about this thick, how to build every part and piece that was created from the mock-up.
And lots of tight mechanical controls for diagrams and labs and things like that. So
That's right.
on top of everything else.
That's right.
Yeah, I think we had a great team. Couldn't have been as successful as that. This was one of my favorite projects in terms of that, and a lot of fun. Yeah,
That's right.
Finally
High five,
coming
high
out.
five. That's right.
We're going out today. This is a fun
That's right.
job. Any questions?
So, being an engineering building, did you have like engineering gods kind of overlooking, kind of keeping an eye on you when you knew you had to do something very special, and if you screwed up, you'd be ruining engineers for decades to come?
The engineers weren't here yet.
Yeah,
Oh.
I never
for the
felt that
engineers.
way. I never
Yeah.
felt that way, but I think we all
It was
felt
architects right up until it was engineers.
And then, do you have any of the engineers? Did you bring any of the students? Were they involved in any way, or have they now come on and go?
in the program.
We hired a
Yeah.
few interns who are now actually one's a thriving superintendent with Clark Construction. So not on my development group, but on the contractor.
But with respect to the engineering students that were going to be in this building, I think that was part of the GW's early programming discussions. But they weren't involved by the time we got here.
And they actually, interesting fact, they moved in 1 weekend. 1 weekend, they all moved in. It was incredible. So literally the building doors opened and the trucks just backed up for days on end. It was crazy.
Was Clark involved earlier on as more like a design build type thing, like super early on? And then were there any key subcontractors that you brought on early as well?
Back to the team, this was a village. So years before GW had hired Boston Properties, as an owner's representative who worked through them tirelessly for years on programming, because when you're going to make this expensive commitment, you have to know what you're going to do, have an idea. About a year or two into that, Clark was involved in the early budgeting, but Ballinger was involved 2 years in before all of that, visioning, coming up with how this would work. And then this was 2 years in the ground, kind of coming out of the ground with the structure, long time frame, which allowed for a lot of that. And so, count my floors here, 6 floors were part of a first phase, and 2 floors came after, and it kind of caught up basically to that design. So lots of VA and analysis and everything that went with it. One interesting fact, there are 2 dorms there and there. The way to support those, 85 feet down, off each other. So they were literally supporting each other. The excavation and the supportive excavation on this job was incredible. Amada's right there. There's a clean room like 12 feet from the tunnel. Electromagnetic, resistance reinforcement. It's about this thick on those walls. Just, you could not have picked a more complicated place. Blasting rock with an active hospital. Wild, really wild.